everybody. Welcome to another interesting session in the math class where today we're going to look at interesting topic in matrix linear algebra called as eigenvalues and eigenvectors, right? So in one of my previous videos, so you might have learned what are matrices and determinants when it comes to, interpreting them in geometrical terms, right? So let's have a relook at that so like we can relate to what we are discussing today. So let me show you on the whiteboard. So we all recollect that if you draw the x-axis and then y-axis in your coordinate system like this, you know that you have, say, a vector whose dimensions are, say, 2, 1, right? So the x-coordinate is 2 and y-coordinate is 1. And then if we subject to this matrix transformation, like, say, 3, 0, 0, 2. So what's happening here is that your x-axis, which was basically the unit vector 1, 0, is being transformed to 3, 0. So anything in the x direction is being stretched 3 times, right? 1, 2, and 3. So your x-coordinate 2 becomes 2 multiplied by 3, that is 6. And the 0, 2 means your original unit vector in the y direction, that is 0, 1, is now becoming 0, 2. So anything in the y direction is being stretched 2 times, right? 1 and 2. So your 1 becomes 1 into 2 equals 2, right? So your 2, 1 has now become 6, 2, right? But similarly, if this was not 3, 0, suppose this was 3, 1, and then this, instead of 0, 2, this was like, say, 2, 2, right? In that case, your x-axis would have, your x unit vector would have been stretched 3 times in the x direction, and then you would have had 1 unit in the y direction as well. So this would have become something like this. And then this, instead of 0, 2, if it was 2, 2, then your y would have become like 2 units here and then 2 units on the top. So this would have become something like this, right? So your vector, now instead of this, it becomes something like this, right? So you see it's getting stretched as well as it's changing its direction by, say, an angle, right? So usually this is what happens. Your original vector in the original coordinate system is going to be getting stretched like this, as well as it's going to be changing its angle, right? But sometimes it's quite possible that a particular matrix transformation, like say A, B, C, D, right? If you apply that on some vector, like say x1, y1, it might result in only the stretching of the vector and not a change in this direction. It's quite possible that can happen. Let me show you with an example on the screen. So if you look at this GIF, right? So what's happening is the yellow line is the vector, right? The yellow line is the vector. So just look at that once again. The yellow line is the vector in the original coordinate system, and this 3012 is a matrix transformation. So the green line is the x-axis and the red line is the y-axis. And you see after the matrix transformation, the green line and the red line, they change their orientations, which results in only a stretching of the vector, right? The vector is not changing its direction. It's stretching on the same line. So if this sort of scenario happens that the vector stretches or compresses on the same line, right, instead of changing its direction, then such a vector is called as an eigenvector, right? It's called as an eigenvector, and the amount by which it stretches it is called as the eigenvalue, right? So coming back, say if a vector v, after applying a matrix transformation A, results only in stretching of the vector, let's say the value by which it stretches is lambda, right? The Greek letter lambda, this one, right? So a particular matrix transformation, like say A, B, C, D, after being applied to a vector, results only in multiplying the vector by a constant, which is basically stretching the length of the vector, stretching or maybe compressing, whatever. If it's compressing, then this lambda is going to be some decimal number, let's say 0.5 or 0.4. If it's stretching, then this lambda is going to be some number greater than 1, like say lambda equals 2, 3, 10, 50, whatever, right? If such a scenario exists, then such a vector is called as an eigenvector of this matrix, all right, eigenvector of this matrix. And the value by which it stretches is called as the eigenvalue, right? I hope this is clear. So that's basically the meaning of eigenvector and eigenvalue, right? So in the next video, we would see how we basically compute the eigenvalues and eigenvectors of a particular matrix transformation, all right? So stay tuned for that video. We'll have a look at that in a separate video. So until then, take care, bye-bye, and I'll see you next in another video on this topic. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another video. Bye bye.